Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics and still on the daily platform of working on different topics that we shall be having. Still a continuation on exponents and logarithms. So this is the fourth class that we are having, that we are going to actually focus on solving logarithmic equations. So we have a condition where we are going to work with logarithms, but this time we are solving logarithmic equations. Okay, so actually there are so many concepts that we can use in different conditions, so I want you to just take a consideration from what we referred in our last class. We said let's say we are given log a base b, which is equal to c, like that. This is actually a logarithmic equation because we are given something that is in log form. All right, so what you are supposed to do in this case is to at least rewrite this in exponential form, because we know that we can solve equations actually in exponential form. So you're supposed to rearrange. So remember, I said we are going to write a is equal to b to the exponent of c. It's now in exponential form, so that can be a consideration of the first type of an equation that you want to solve. So how now am I going to solve such type of an equation using this concept? Okay, I want you to take a consideration of what is happening on this exercise here. We are asked to determine the replacement that will make each of the statements true, that is, you're actually finding for x, which is the same thing on number 2 there. Solve the following logarithmic equations for x, which is the same thing on number 3, which is the same thing on number 4 there. All right, so these are the typical cases that you can actually have. So in this case, we are given, let's work with the number 1 there. This is log n base 3, which is equal to 6. All right, so using this concept, how can I find the value of n? Because I need this value of n. That's the one that I need to calculate. So I'm just going to apply this concept here. Remember, we said we can convert to exponential form, which is this n is representing our a here. So it's n is equal to, remember, base to the exponent of c. So this is your base 3 to the exponent of the answer, which is 6. So which means your n is going to be 3 to the exponent of what? Of 6, of which this part you can actually just use your calculator to simplify this. Right, something like that there. That's 3 to the exponent of 6, which is going to give us something like 729. All right, so that's what we have there. So our n is going to be 729. So it means for this part to balance, it actually means the logarithm of n, which is 729 in base of 3, must give us a 6. Okay, so let's see what we're talking about here. Sorry for this light. There's too much light there. Okay, it's log of a number, remember 729 in base 3. Okay, so I'm just gonna do this. Base 3 of 729. We must obtain the same number, which is 6. Are we obtaining? Yes, that's the number that we're obtaining, which is what? Which is 6 there. All right, so as you can see, it's actually balancing from what we were given. All right, so that's how you actually use this concept, because you know that you can solve anything that it is in exponential form. You can solve for anything. Okay, let's take a consideration of this part here. I'm given now to solve for x, but this time my x is a base, log 1 over 27 in base x, which is equal to minus 3. All right, this is what I want to solve. It's another for the other part there. How am I going to solve this type of an equation? That's the question that you'll be having there. All right, since we have the consideration that we talked about here, we're just going to apply the same thing, our base to the exponent of c is equal to a. So a is the number that is affected by our log. So in this case, the number that we are talking about is this number, which is 1 over 27. That is the number that we are referring to. So we are simply saying 1 over 27 in this case is equal to the base to the exponent of what? Of the answer that we are given. So that's x to the exponent of minus 3, like that. All right. Remember what we did last time when we were in exponents, when we were actually working on a separate part of exponents and we were solving exponential equations. There was a type of equation like this where you solve for x and x is given as a base, if you still remember that. And there was a condition where you solve for x and x is on the exponent, like this, where we said when it is on the exponent we can actually make like bases. But if x is in the base like this, remember what we said, we are going to find the inverse of this number, which is minus 3. So what is the inverse? Because we want to remove this minus 3. So minus 3, the inverse of minus 3 is simply 1 over minus 3. That is the inverse of what? Of minus 3. And 1 over minus 3 is going to give you minus 1 over 3. Remember, guys, from the concept that we talked about, that inverse is simply 1 over a number. All right. Because logarithms are no longer playing a part. We are now solving a normal equation, which is actually the equation that we are actually used to, that is on exponents there. I don't know what's happening with this thing here. All right, let's try. So we are going to multiply by the inverse both here and also on this part. All right. So this number 27, remember 1 over 27 means 27 to the exponent of negative 1. That is 1 over 27. Okay. X to the exponent of minus 3. All right. Now let's multiply by the inverse, because we are finding the inverse where there is x. So the inverse of x of 3 minus 3 is minus 1 over 3. So you're going to multiply by the inverse both sides by minus 1 over 3 by minus 1 over 3. You are multiplying the exponents because this is the inverse of the exponent. So it must multiply the exponent. Okay. So if you multiply from your calculator, minus 1 times minus 1 over 3. So guys, I want you to multiply as you saw that there's too much light there. So just multiply this minus 1 and minus 1 over 3. It's going to give you a positive. So that's going to be positive 1 over 3, which is equal to, if you multiply minus 3 times minus 1 over 3, this is going to give you a positive 1, which means it is the same thing as just having x, because x to the exponent of 1 is same as x. Any number to the exponent of 1 remains as it is. If it is 10 to the exponent of 1, it remains as 10. All right. So that is it, guys. Now from your calculator, 27 to the exponent of 1 over 3 is going to give you x. So x is going to be 3. So make sure that you use the calculator properly there to evaluate that exponent that you are given, 27 to the exponent of 1 over 3. So as you can see, guys, that's how these questions actually can be asked. That's how they ask these questions. And you must be very, very familiar with these questions. Now they can ask something like this, which is this is question on it's number 2E. It's on number 2E there, which is written as that's log x base b is equal to 0, like that. Okay, and we are solving for x. So this actually, we are actually solving for x there. We are actually solving for x. All right, for each and every part that you are going to have with x, that is what you're going to be solving for the meantime. All right, so we want to solve for x there. And how can we solve, guys, this part? Okay, still using the same concept. Remember, in exponential form, we said you're going to take the base as it is. So x the number as it is, which is equal to the base to the exponent of the answer, that is b to the exponent of 0. So x is equal to, remember, any number to the exponent of 0 gives us a 1. So therefore, x is equal to 1. That is what we are having. So we have calculated the value of x, guys, okay? So as you can see, it's not even much. What about this one? On f, I want you to take note there, on 2f there, that question, we are given that log x is equal to minus 3, and you want to calculate the value of x, while we are given that log x is equal to minus 3. All right. In this case, as we can see, we can't see the base. The base is not given because a log is supposed to have a number and a base. So remember what I told you guys on the introduction of logarithms, that when the base is not indicated, it means you are in base 10. So it's log x base 10 is equal to minus 3. Now we can solve. Remember, the number x is equal to the base to the exponent of the answer, that is 10 to the exponent of minus 3. So if that's the case, what is 10 to the exponent of 3? So as you can see, already we've got x. There's nothing that we can do here. Already it's x. It was different from the other questions where we have to remove x, guys, like this one. I want you to see here. If you were to cross-check here, our x was not direct. We had to remove the exponent because there was an exponent which was affecting x. That is why we had to do all these procedures. But in this case, we can't do that procedure because there is no exponent here on x. So what you simply need is to evaluate this from your calculator. Okay, so it's going to give you 1 over 1000. So that will be the value of x there, which is 1 over 1000. All right, so that's how, guys, they ask you, can you cross-check also on number on 2g there? We have got the same thing. Okay, let's just do this. 2g, we've got the same thing because we are given this as log 1000 this time is equal to x. This time x is the answer, like that. Log 1000 is equal to x. Okay, so how are you going to solve this? Just like what you did in the previous question, we are not given the base, so it means we are in base 10. So this is going to give us logarithm of 1000 in base 10, which is equal to x, just like that. Okay, so the number 1000 is equal to the base to the exponent of the answer there, so that's 10 to the exponent of x. So we are now in exponential equations. We are no longer having a log there. It's all about exponents. So taking you back, guys, to the exponents, we talked about this type of an equation where the exponent is the value that you want to calculate, which is the unknown value. So we are going to talk about like bases in this case. So can we make these two bases to be the same? Is that possible, guys? Can we make 1010 to be in the same base? All right, yes, it's possible. 10 to the 10, there's nothing that I can do on 10. It's already in its simplest form, so it's just going to remain as 10. But what about 1000? Can I write 1000 in the base of 10? Yes, it's possible, because we know that 10 to the exponent of 3 is 1000. So remember, I told you, you try 10 to the exponent of 1, you obtain a 10, 10 to the exponent of 2, you obtain a 100, 10 to the exponent of 3, you're going to obtain 1000. So it means this can be written as 10 to the exponent of 3. So if this can be written as 10 to the exponent of 3 like this, and the bases are the same, you are going to equate that the exponents. So 3 is equal to x. So if 3 is equal to x, it means x is equal to 3. It's one and the same thing. Just like a is equal to b, b is equal to a. It means one and the same thing. So if x3 is equal to x, it means x is equal to 3. We are solving for x. That's why we have to write our answer as x is equal to. Okay, just a normal way of working or calculating these. Okay, so that's how you're going to answer these questions, guys. And I think the best that you're going to actually do is to work these questions from past exam papers so that you can understand much better. That is going to be the way there. Okay, then there are some cases which are so weird, just like this, guys. Log 2 plus log x is equivalent to log, let's say log 10, like that. All right, you want to solve for x there, and you're given that log 2 plus log x is equal. This is an example that I want you to first have, so that maybe we can use it to answer the other questions. All right, if you are given a question which has got logarithms throughout, there is no number like we are not given a number like this part where we had something like maybe we can just say log x is equal to 1. We are not given a condition like that, sorry, like log x is equal to 1. This part that I was saying here, we are not given that condition. So if this be the condition now where I just have logarithms throughout the question, so in this case I'm saying we are having logarithms throughout the whole question. It's log here, it's log here, it's log here. Which concept am I going to use? Okay, this is the concept that you're going to use. Take note here. If log A is equal to log B, okay, provided that the base are the same. So in this case, if I didn't indicate the base like that, it means we are in base what? We are in base 10. So you can use any base of your choice here. So if these two bases are the same and these two logarithms are equal, therefore it means that A is equal to B. That is the concept there. There is no way that these two logarithms can be equal whilst these two bases are the same. There is no way that these two logarithms will be equal and these two numbers will be different. It doesn't make sense. What I'm trying to say is this. It does not make sense to say log 2 base 3 is equal to log 5 base 3. Whilst we are in base 3 and we are in base 3, these two numbers should be equal. So this is actually wrong. But it's very true to say if I am having log 2 base 3, it can't be equal to anything. It is going to just remain as log 2 base 3. So this can be taken as an advantage to say when two logarithms are equal and I am given something like this, all right, log x base 2 is equal to let's just say base 3 like this, okay, base 3 is equal to log 2 base 3. Since these are equal, are the same, log base 3 and log base 3, it means x is equal to 3. So therefore x is equal to 2, sorry, x is equal to 2. By default, just like what you had, 2 to the exponent of x is equal to 2 to the exponent of 3. By default, when these are the same, x is equal to 3. So it's the same thing also on logarithms. By default, when these are the same, it means x is equal to 2. That is the idea there. So it only happens when you are given a single logarithm and another single logarithm. Now let's cross-check our question here. Yes, we've got logarithms throughout the question, but these are not single logarithms because we are given on the left-hand side here, these two logarithms are adding. So which base are we talking about? We're talking about base 10 in this case. This one is same as we are in base 10, we are in base 10, we are in base 10. So you are adding, you're going to multiply the numbers. Remember the concept of logarithms. When you're adding log A to log B, you're going to multiply the numbers. Provided that the bases are the same, you're going to multiply the numbers there. All right, so that is the case here, so that you can obtain a single logarithm. So you're going to multiply 2 times x, which is 2x, and we are in base what? We are in base 10, which is equal to log 10, which is in base 10. So as we can see, we are now having the same thing here on the left hand side, and on the right hand side we now have a single. So when I'm saying a single logarithm, we are talking about one log like this, not to have log here and another log here. This is a single log, this is a single log, and as you can see, log base 10 and log base 10 are the same. So it means 2x is equal to 10. That is what is left. So if 2x is equal to 10, divide by 2 here, your x is going to remain as a 5. So that is what you have there. So as you can see, guys, it can be quite simpler to solve a lot of questions. It can be quite simpler, guys. Why am I saying so, guys, that it can be quite simpler? That is a condition what you can have, but if you are given a condition, maybe it's not possible for you to do that. Like this condition, it's not possible for us to do this, but what can we do now? It's log x. We've got log x there, plus log 250 plus log 250, which is equal to 3. That is on number 3a. On number 3a there. What can I do this time? What am I going to actually do, guys? Okay, this is the concept here. Since I can combine, because here there's no log, it's just a number 3. Let's just try to combine. That's the only thing that, guys, we can do, because here there's a number 3. So it's now different from the last question where we had got 3 logarithms, where we've got another log there. This one is a number, it's not a log. Okay, so but here the base are the same, because this is base 10 and base 10, because it's not given a base, so you know that you're in base 10 by default. Okay, so that one you must indicate. So we are back to adding of logarithms. We are going to multiply the numbers, which is x times 250. So it's going to be 250x. You're multiplying x to 250, that's 250x by the base. We are in base 10, which is equal to 3. So now it makes sense. We can actually use the previous concept. This time it's not a single log. It's not, we do not have a log here, we just have a log on this side. So which concept are you going to use? Remember the concept of changing from log form to exponential form. That is what you're going to have. So that is going to be 250x is equal to the base to the exponent of x. That is 10 to the exponent of 3, not x. Okay, so once at this stage, what am I going to do? This is 250x. These two numbers are multiplying, so you can just leave it like that. 250x is equal to, I have to simplify, 10 to the exponent of 3, which is going to give me 1,000. So what can I do now, guys? This is the question that we now have. How can I remove this 250, this one? How can I remove this? What is this 250 actually doing? How is it affecting the x? How is it affecting? It's multiplying. So how do I remove this? I have to divide, because I'm multiplying here. Divide by 250. So that's going to give us the value of x, which is equivalent to a 4. So that's what we have there. So as you can see, guys, there are so many typical questions that we have. So the next class that we shall be having, or the next class that we shall meet, it will be on revisions now, on exponents and logarithms from past exam papers, so that we can see the information that we have covered, all the information that we had in our classes. How do they ask these questions? So not to miss these classes, make sure that you become part of the family by subscribing to Meson African Motives channel, so that we will be part of the classes that we are working on revisions, and also on daily classes that we shall be having. So that's it, guys, from Meson African Motives. Till we meet again.